All right, so what if we have just tangent theta? Well, there's no derivative that gives us tangent theta. It has parts that are tangent, and so that's what we need to do. We need to make this into something that we know we have. So that right there. So if I do that, I have to do this as well. And then everything just appears. So I know, well, if I make my u equal to secant theta, my du would be secant theta d theta. So it's a little, it wouldn't be that. It would be secant theta tangent theta d theta. This is what happens when you don't think. There we go. So that right there is my du. So I end up with 1 over u du, which we know is the natural log of u plus c. And then if I plug it back in, there we go. And so this is what we can now use. Every single time you see the integral of tangent theta, we know it's the natural log of secant theta plus c. Well, what if you have tangent squared? Well, tangent squared, we can use our Pythagorean identity, which is secant squared theta minus 1 d theta. And we already know the integral of secant squared. I don't have to even write it. This is tangent theta minus theta plus c. So if you see a tangent squared, just immediately replace it. All right, let's try another one. Tangent cubed. We're just going to keep working our way down. So when you think of this, we think, okay, well, if we do this, I can now replace it. So that should be your first thought. So then we go tangent theta, and then this is secant squared theta minus 1 d theta, and you go, oh, look at that, right? Because I don't see anything, but you do. So what you want to do next is this. You just distribute it. These are just, you're going to keep just throwing stuff at it until it works, but this one with the tangent cube is going to work. So now you may notice, oh wait, look, I can break this up. That's tangent theta secant squared theta, right? That's our odd from before, minus the integral of tangent theta d theta, which we just found earlier. So now if I come over here and say u equals tangent theta du equals secant squared theta. So it's just our odd tangent again over there. So we have an odd tangent and we have a secant squared off to the side. We can then plug it back in. So this becomes u du minus, and I'm just going to go for that one right there because we already know it. It's natural log of secant. So ln secant theta plus c. And then this is just 1/2 u squared. So if we put all this together, we end up with 1/2 tangent squared theta. Bring this down so that we have it like that. Minus natural log of secant theta plus c. And then we integrated it. So you're throwing all your tricks at it. If you see tangents, if we make a square, we can then throw in the secant, distribute, and see what happens. And we've got u substitution. We have integration by parts. We've got a lot of different tricks that we're going to be applying to these. All right, so what about tangent fourth? Well, why don't we do exactly the same thing we just did? That's tangent squared theta, tangent squared theta, d theta. And then now we can say, well, that's tangent squared theta, sorry, almost said it backwards there, secant squared theta minus 1 d theta. And we could even change this into secant squared minus 1 and then just do distributing from there as well. But I'm going to leave it the way it is. So this is tangent squared theta, secant squared theta, because I'm going after that even secant. And we already did tangent squared up there, so I'm not going to do it again. Tangent squared would have been secant squared minus 1. So now we can just replace that with minus tangent theta plus c. And then now we have to deal with this one. Well, this is just an even secant. So what do we do with an even secant? That's right, you make it u equals tangent theta, du equals secant squared theta d theta. We're supposed to pull off a secant squared. It's already there. So now we can just do a quick little u substitution. So u squared du. So this is 1/3 u cubed. And plugging it all together now, 1/3 u cubed tangent. So 1/3 tangent cubed theta minus tangent theta plus c. And there you have it. So this is obviously a lot more complicated than the other ones, but the whole point of this is you've got to use all those tricks. We're going to use substitution. We're going to be breaking it apart into different ones. This is not the only way you could have done this. We could have done a secant squared minus 1 and then distributed that out, and you're going to get a secant to the 4th, and then you could break it apart. But it's the same basic idea, just a lot of substituting and u substitution. And then in the next video, we will do some differentiation in parts by parts. Integration by parts, sorry.